Hi, everyone. My name is Rich Horace. I'm a principal consultant at my company called Secret Sauce Ops. And I want to kind of share a little bit about my background where, when I was building my second DevOps team, I really wanted to be the secret sauce of the company. And one of the major pieces around that, a major ingredient, was the Elastic Stack. It provided us a level of visibility for application and infrastructure, and it was one of the key applications that we had when I was at that company. So now I'm trying to do the same independently, trying to do a DevOps consultant and Elasticsearch consultant. Today I'm joined by Itamar Sin Hersherko, the CTO and founder of Big Data Boutique. He's going to be talking about Elasticsearch performance, cost efficiency, and production. And so for the agenda, we'll take care of some housekeeping. We'll talk about the Elastic community. We'll do a little bit of a speaker spotlight. Itamar will do his talk and demo, and we'll have a Q&A. And also, we're going to have a raffle at the end. So you're going to stay to the very end. And you can see that QR code on the right. You can register for the raffle. So it's a $50 and $100 Amazon cards. Oh, sorry. Sorry, my mouse. I'm trying to get my mouse in the right spot. There we go. Okay. So the Elastic community is pretty big. I mean, it's worldwide, 150 different groups all over the globe. I've been running the Elastic LA meetup since 2015, and when I was implementing my Elastic Stack, I got really excited when I saw the newer versions of Kibana, and I was looking around for the Elastic LA user group, and I found that they needed someone to be an organizer, so I immediately signed up for that. And 9 years later, 75 plus meetups is a great opportunity. You get to meet people in your community, you get to share, and just build the community around Elasticsearch, especially if where your journey is within that. So definitely, there's some great resources. There is the Discuss Elastic.co, which is the forum. You can ask any questions there and get feedback. There's also the community newsletter. And also, they've launched a couple other sites for Elastic Observability Labs and also Search Labs. So you can go down the observability or dive deeper into the search components. And you can find more at elastic.co/community. And I encourage you all to check that out. Definitely sign up for the newsletter. And whatever brought you to today's webinar / virtual meetup, definitely keep your eyes out for different events in your area or even online. So let's so Itamar and I have kind of crossed paths over the course of time. I know he's been working with Elastic even longer than me, and we have this is actually his second meetup with us. And the last time I made him get up at 4 a.m. to actually do a nighttime session with us on the Elastic LA meetup. So this time we're doing a little bit earlier, trying to get more time zones. But I really like to everyone to get a little more background that probably won't come up in this presentation. So when we dive in, so Big Data Boutique, how long ago was it this launched, and is it the complete Elastic Stack, or is it really focused on the data side with Elasticsearch?
First of all, thank you for hosting me. Great to see you again, and thank you for all the good folks from Elastic for setting this up. I've been doing Elasticsearch for over 14 years, since very early versions, so 0.10, I believe, or something like that, and code contributions, docs contributions ever since. A big data boutique, the company that I'm leading now, has been around since 2015. And for about, I guess, I'm terrible at math, but I guess 9 years
Close to 10.
almost.
Yeah.
Yeah. And the first time I actually gave a presentation in Elastic LA meetup was actually in person. It was actually almost 10 years ago, so October 2014. I just looked it up before we went on this one, so it's quite a nice, I would say, closure. And yeah, so it started with a one-man show giving consulting and training, and then it's a whole shop doing a lot of Elasticsearch work now.
And then is it, are you mostly focused on Elasticsearch itself or the full stack?
Yeah, so a lot of Elasticsearch, because the core on its own is huge and you can do quite a lot of things with it. But we also find ourselves doing a lot of Elastic Stack stuff. So it's sometimes integrating APM, sometimes it's going and doing performance optimizations for Elasticsearch powering SIEM, and then integrating some things over there, and so on. So we do meet the stack a lot. Definitely the open source tools of it, so Logstash, Kibana, and other parts of it. But I would say our specialty, really expertise, is really with the core itself, and we just do a lot of things over there.
Yeah, I think it's one thing that's overlooked about Elastic itself. It's like it's not one size fit all. You can really mix and match your components, and Elasticsearch can just stand by itself as the tool product or however you're building things around. And then, Kibana is really grown from just being the visualization to being the management of the stack. So those always recommend, hey, releasing those two to kind of get the true visibility into how things are performing. And then how is what are some of the challenges around Elastic velocity of how fast they move? I mean, essentially every 6 to 8 weeks, there's a new release. Every year and a half, it's a major release, definitely based off what they're doing with Lucene. But I'm curious, what's the most recent, oldest version of Elasticsearch you'd work with? As a company.
So you had two questions there. So it's really hard to track the velocity and track everything that's going on. I used to do that, on almost on the commit or PR level, but I don't have a lot of time now. So it's mostly, chasing the release notes and changelog on a very high level. And we also do that mostly for the core. So again, so hard to keep track. And that's why we choose to be focused on core Elasticsearch and then support everything else beyond that. I have recently saw 1.7 in the wild, and we are currently supporting several customers with 2.4. Don't ask, I won't tell, but some are still stuck on those versions.
Yeah, my upgrade from 1.7 to 2.0 was definitely probably the biggest challenge I had. When I jumped in, Elasticsearch is already 1 dot something. So I should pull it up. I found a note that has my first version of Logstash, Kibana, and Elasticsearch. I'll have to post that like on Throwback Thursday somewhere. So what's has been like one implementation of Elastic that has like been like, wow, this is a pretty cool solution? Do you have like any, because you've seen hundreds of installations, that's probably the really cool part about supporting the customer base around that. But what's been like the one thing that at least one or two, like, yeah, this is pretty cool?
So that's a good question. So I think one of the more innovative use cases we saw way before there was vector search and all of that was searching for videos or sequences in videos. So basically saying, I have this frame, I want to find that frame and then using span queries. I don't know how many implementations you saw that actually use span queries. So they use span queries to actually do that kind of thing. So searching videos, it's more common now that you have vectors and embeddings, but it was so not common back then, so many years ago. And I think the other one that is actually recent, a customer of ours, Notion. I'm sure many of our audience know them. So we work closely with them on both performance and optimizations, but also on improving their search. And there's a lot of things going on there. So learning to rank, LTR, and maybe and a lot of ML related optimizations over there. So they're really pushing the boundaries and on what you can do with search, even plain search, not even vectors and embeddings. And it's really interesting what they're doing there.
Yeah, I think the coolest thing I've seen was actually because NASA and JPL getting the Mars rover data, and the Elasticsearch engineer actually presented at the meetup and talked about they had like a small window when the satellite would be in the right position to actually get the data from the Mars rover. I think that's still the coolest I've seen so far. And now that you brought up vectors, I think why don't we just talk about we've gone already 12 minutes without
12
talking
minutes
about
without
AI.
Yeah.
So basically, so you are doing some stuff with I mean Notions. You just said they're kind of doing some stuff, or where do you see Elastic overall? Because it's really where do they fit in the AI ecosystem from what you've seen so far?
So I think it started slow. So sparse vectors, dense vectors have been around or available in Elasticsearch, even if it was sort of preview for quite a long time now. So several years, I believe. So I would say 3 years. And it's kind of been slow. And then we mainly saw, how you use ML in Elasticsearch to do things like anomaly detection and things like that. But then suddenly it was using Elasticsearch as the core for Gen AI or in general AI. Right now, we build a lot of Gen AI applications. We even have some internal tooling that we will probably release in open source because it's growing nicely. We call that Shraga. And it's basically a software that helps us deliver RAG applications really fast. And Elasticsearch is very much the core of that. So it's the engine behind that, and the performance, the capabilities. They keep adding retrievers and all that, and various embedding models that are available within the core. So it's one of the big contenders, I would say. Also because it's a very well-known, well-understood technology with the managed offering as well. So all in all, it's definitely a technology that we see a lot being used in the AI, Gen AI space as the core for that.
Yeah, I think I've been following it all along and just learning that it was, the vector database implementation was from 2019 to 2020, and they were ready and kind of moving in that direction. And when I do talk about it, it's like, well, it's another data pipeline at the end of the day from a simple thing. And that's one thing that Elastic's been great at,
Yep.
ingesting data. And it's just, and they're making improvements from when they really kind of did the announcement last September, and kind of saying, hey, we're an AI search company now, and but as they move forward, I really like they're making it easier to work with on the newer versions. But in the last couple meetups I've had solutions architects from Elastic. And they're like, well, yeah, we're the largest vector database in the world, but they're still talking about it just really becomes that other field, field in the index and how it can work. So it's pretty cool.
Yeah, and remember, it's not enough to have a vector database. You need to do hybrid search, and
Exactly.
Elasticsearch is great at the other side of things for the hybrid.
Yeah. Yes, exactly. And why don't we transition to into Pulse? I know that Pulse was an internal project initially. Why don't you kind of just share a little bit of how we evolved, and like when was the light bulb that says, hey, you know what, we can make this a SaaS product and offer it out there as another solution. And was this like the first SaaS product that you've worked with in your background? I could kind of assume that you've done a lot of back end, but have you done a SaaS company as this?
So we, as a an entrepreneur, I would say you build stuff and you scrap stuff. So we did that quite a bit. We built various products or toolings, and nothing really proved itself. But Pulse really was born out of a decade of doing consulting and performance optimizations. And like I said, we work a lot with core Elasticsearch, and basically seeing all of everything over and over again. So I have this problem, the nodes crash, queries are slow, and then you get to a point where you tell them, okay, show us the dashboards, and either they don't have them, or they have something very, very basic. I don't know, Kibana monitoring, that is great, but for example, it doesn't show all nodes in one graph, or Grafana dashboards that are plotting, based on dashboards that you take for the marketplace. But it wasn't as deep as you actually need to start debugging stuff, hot threads and things like that. And we worked a lot of time with customers to build dashboards sometimes and improve what they have, either from scratch or from 5 and get to 10. And then it just wasted a lot of their time and hours. And we just thought how we can do it even better. So we went ahead and told them, okay, just use MetricBit and send the metrics to us. And they started doing that. We started ingesting, we started graphing, and then we also realized, well, we have all those metrics. We could just as well tell them, do this, do that, or heuristically look at things and kind of suggest things to do. And that's how Pulse was born. It was born just as a managed dashboards offering, and then evolved from there. And I built SaaS applications before with my team, but it's really the first one that really evolved into a full-fledged product and software company essentially.
Excellent. I think it's cool. And that's I think it's a nice. And how's the adoption been so far? So you launched 2 months ago, almost 3 months ago.
We officially launched 2 months ago. It's been in the works for 4 or 5 years now, but we officially launched the full package that we have just a few months ago, and it was quite launched before that. We have quite nice adoption already. A lot of paying customers, and really big ones. Some I can mention, some I cannot. And we're very happy to have them with us, and the future looks bright.
Excellent. All right. Well, we can dive into your presentation then. Thank
Sure.
you.
So yeah. So I would show us a couple of things with Pulse, and obviously our session today, the title is about cost and performance optimizations. So obviously it will be useful, but I would want to basically share some things that we've seen over the years, and also some probably new topics over there. So introduction, we basically did that. Maybe I'll just briefly close in a couple of gaps, and then we'll just start discussing the session topics. I would cover the cost and performance trade-off, which is something that's worth noting. You cannot really optimize for performance and also hope for cost to be reduced. It's some sort of a trade-off that you need to take into account. We'll talk about right sizing, which is really the answer to that. You need to find the right balance, which is the right balance for you. So we'll talk about some rules of thumb on right sizing your cluster. And then what kind of metrics you would want to monitor to make sure that you are on that sweet spot. And then talk about a couple of things we've seen in the wild, like indexing and sharding strategy that is sometimes overlooked or done wrong. And then slow queries, which I think is a big topic, but we'll get to that almost last for some reasons that we'll discuss. And lastly, we'll touch on vector search, which, like you said, is a big topic right now. And I did want to make sure that we include that in our session. So again, briefly, we are Big Data Boutique. We're a globally distributed team of big data experts, and we're doing a lot of things around the big data world right now. So a lot of Iceberg and Spark and Flink and ClickHouse and other technologies like that. But really our bread and butter is Elasticsearch. It's something I've been doing for over 14 years. The team with me is doing that for many, many years. And we've been seeing a lot of customers doing a lot of really interesting stuff and really challenging things as well. It could be huge clusters, it could be many clusters, and so on. Out of that, we've produced pools, and pools is really the way to create smart and proactive monitoring for Elasticsearch. So instead of spending a lot of time and inducing a lot of maintenance toil, even if you're running on Elastic Cloud, there's still a lot of applicative items that you need to take into account: sharding, indexing, index mappings, all of those things, even if the infra is handled for you. And then pools is exactly for that. It covers infra if needed, if you're running Elasticsearch on your own, or and also the applicative side of things if you're running that's helpful also if you're running on Elastic Cloud. The way that we look at it, we basically look at a couple of different personas that would manage the cluster. They could be very technical, they could be the managerial roles, and what we want to do is kind of provide the bottom line. So we still have those dashboards that I mentioned that we originally created pools for, but what we see is that actually 80% of our customers don't even go there. They'll only be interested in the bottom line. So what is the health assessment for my cluster? This kind of operational review. You're doing this right, you're doing this wrong, providing you those actionable insights and recommendations. And then obviously we do have monitoring, we do have dashboards, we have alerting, which we think are smart alerts, not just threshold alerts, anomaly detection, and other things that are very much tailored to Elasticsearch. And then obviously everything we can do around right sizing and cost optimization, the platform will provide. And from here we can jump to the actual content. So with Elasticsearch, I wanted to split this discussion into several different use cases, or at least highlight that there are those different use cases. There's search, which is traditional search, vector search, hybrid search. That's the core. That's what we've been doing quite a lot. In addition to that, we have logs and analytics, which is also what I would call core usages. So just Kibana, or you're building something on your own to display dashboards from your application, and you're just querying Elasticsearch from there. And then there's all the Elastic Stack applications. So Elastic Stack, the solutions that the Elastic Stack provides, already contain a lot of those optimizations that we're going to talk about today. But sometimes there are those places where, for example, you're running Elastic SIEM and you're running this on your own, and you still need to take into account how you're running that and make sure it's right size and so on. So those are, if you're running on the cloud, it's definitely not as interesting. But if you are running that on-prem and there's still customers doing that, that's interesting there. And then RAG and Gen AI, that thing that we discussed just a few minutes before, that's a huge use case that's getting a lot of traction right now, and it needs to be done right. I would say proper RAGs will actually run quite a few search queries to Elasticsearch, and those would be vector searches, obviously, but also hybrid searches. So you'll find yourself doing searches that involve keyword search and vectors, and doing sometimes very heavy operations, but also multiple queries in one RAG session. So you ask a question, you ask an AI agent a question, and it will basically run multiple queries because, I don't know, it split the question into multiple individual questions. So that's something we definitely need to take into account, and it's definitely a use case that we need to attend to. So as cost and performance go, it's not a zero-sum game. It's you need to basically take into account that there is trade-off over there. In order to achieve the best stability and performance, and let's focus on performance for a second, a good solution, or a solution that a lot of our customers and many in the world do, is just throw money at the problem. So they will basically just throw more and more hardware, bigger hardware, and a lot of times that works. But what we are after usually is to find that sweet spot between performance, stability, and cost. So you want to spend just the exact amount to get the performance metrics, the KPIs that you're interested in. Maybe you're okay with some searches taking 10 seconds, 30 seconds. Maybe you're fine with that, and that would be good for you to save on cost. Maybe you do want to optimize performance to the max, and you're okay with spending more money. So this is up to you to set the right sweet spot, to find the right sweet spot, and to define those KPIs. But once you've done that, we want to help you optimize on getting there. And that's what we call essentially right sizing. You want to make sure that your cluster is right sized to what you want to get from that. And here we usually split between search and indexing, because that will dictate very different kind of operations or actions that you need to take. And sometimes you need to optimize for both. So if you have huge indexing throughput, for example, the logs use case, and you hardly ever search, then you can take a couple of steps that will make sure that the ingestion tier is very much scalable and strong and can do a lot of things, but you don't really have to take care of the search aspect of it, because when searches will happen, some stuff can be warmed up, and maybe it's okay if searches are returning slower. So that's just one point to remember. But one thing I can tell you is that we see a lot in the wild, and especially on Elastic Cloud, is that customers are actually scaling out way too soon. So scaling out is adding more nodes to the cluster, and Elastic Cloud just makes it very easy in the UI and the auto scaling that is enabled sometimes. And what happens is that we find a lot of clusters that have 10 data nodes, but those data nodes have only 4 cores and 8 GB of memory, for example. And that's not that good. You essentially want to make sure that you scale up as much as possible and as much as makes sense to your workloads way before you're scaling out. So that's one thing to remember. And the usual numbers that we see in the wild that make sense as a rule of thumb would be, let's say, 8 cores, 64 GB of memory. So half of that pretty much is assigned to the heap. Those are the typical numbers you would see. Obviously, sometimes we need more cores. Sometimes it's fine to be with less. Sometimes you can use less memory as well if your workloads are small. But it doesn't make sense to have a lot of very small nodes instead of just consolidating them into one big node first, 2 big nodes, and then scaling out when needed. So just one big tip that we see and something you would want to consider. And then there's the things that are basics with Elasticsearch. So you want to make sure that the heap is no more than 50% of the available memory and never above 30 gigabytes, but you can give it less. Again, if your workloads are smaller, that's already taken care for you on Elastic Cloud, but not something. And it's also checked on bootstraps, some of that on the bootstrap checks. But again, you need to make sure we need to cover all our bases. And then busy data nodes will actually require sometimes more disk throughput, so stronger, better disks than would actually need CPU. So just something to take into account. But both disk throughput and good disk performance and CPU are important for data nodes. That's not very important for client nodes if you have them, or master nodes. There is a misconception that master nodes are very something that's very critical to the cluster. They do a lot of work. They get those requests first and do something with them. That's not true. Masternodes are not doing anything in the cluster, but they need to be there. They need to be as strong as the cluster is big. So if the cluster is not that big, they don't have to be that big as well. As a rule of thumb for data nodes, for the data nodes on the whole tier, we'll talk about tiering in a bit. You want to make sure that the load average metric, that's a Linux metric that we measure, and it's very important for us. So the 5-minute load average metric, we want to make sure that on a decent cluster and a stable cluster, so it does not get a lot of usage spikes, we want to make sure that it's around 70-80% of available cores. So, and I'll show that in a minute, but the idea is that if the load average is 8 and each data node has 8 cores, that basically means that your data nodes are working too hard and you need to scale up or out. So you want to make sure that it's about 70-80% of available cores per node, and that will put you in a good position. Another thing that we see a lot is over provisioned storage. So data nodes that have on AWS, it's EBS drives, on GCP, it's network storage. So they have way over provisioned storage, and that costs a lot. So we want to make sure. Yep.
Emma, we do have one question that came up, and it's kind of about the configuration of the cluster. Are you doing like master nodes, or are you doing like ingest nodes along with this as kind of part of the right sizing? That was kind of one of the questions that just came
in. I skipped that. That's true. So I skipped discussing cluster topologies. Okay. And maybe I should have highlighted that before. On Elasticsearch, once you get to a decent workload, you would want to split between data nodes and master nodes, that's for sure. And that will allow you to gain a lot of stability of the cluster. So master nodes are important to have no noise with them, so they don't need to do anything else but maintain cluster state. And then once you have separate master nodes, data nodes can just concentrate on doing data stuff, ingestion, search, all of that, merges, all of that. Once the cluster grows even bigger, then you want to start splitting out other responsibilities. So ingest nodes will, if you have ingest pipelines, they will run the CPU for the ingestion. So what I'm talking about now is just about data nodes. I mentioned briefly master nodes, just to make sure that they're not over provisioned, so you don't pay too much for them. I'm not going to talk about sizing of client nodes and ingest nodes and ML nodes and the other types of nodes because I'm conscious of time. But each one of them will essentially be have its own metrics or its own things to note. Mostly CPU, but also memory, and I'll show a couple of things around that. Data nodes are the most sensitive nodes, and that's why I'm focusing on them. If there's any other questions, feel free to break in, and that's absolutely fine. So you don't want to have over provisioned storage, but you also want to use the right storage. So for example, if you have a lot of throughput, high ingestion rates, very, very big aggregation queries, that's kind of a lot of disk on each query, then you want to have a very strong disk. For example, local ephemeral NVMe storage drive that are provided in the clouds. Elastic Cloud uses that by default in many cluster types and so on. And I mentioned oversized master nodes. In most clusters, except for very large ones, 1 or 2 cores per master nodes is definitely fine. On smaller clusters, even having data and master nodes on the same nodes is also absolutely fine. And you actually have that on Elastic Cloud by default. And then there's a couple of tricks that you can do there. There's voting on nodes and things like that to just make sure that, again, you don't spend on hardware on smaller clusters. So that's the rules of thumb for right sizing. One thing to note is that what we offer to do in many cases is data tiering. So the data nodes that I just mentioned, needs to be looked at differently depending on what you're doing. So we would want to have different tiers where on some cluster types that will have hot tier nodes, which will essentially take care of indexing as indexing comes in, and serving of real-time data. So think about it, logs use case, for example. You have a lot of data coming in all the time. You're probably querying the last hour, the last few hours, maybe the last day. That's the hot tier. And then last week will be queryable, we will be queried as well, but not as often. And that's the warm tier. So you want to have to do something else with that. And then the other data that you keep for retention or for very less frequent queries, and that's the cold tier, maybe frozen tiers, what we call searchable snapshots. And the idea is that you want to basically spend less on hardware for data that is less interesting or less been accessed less. So based on usage patterns and access patterns, you would want to make sure that you spend the right amount of hardware on that. So take what I discussed earlier about right sizing and then do that on data node sizing, and then apply that on every tier on its own. And that would basically derive, I would say, on large clusters, the biggest benefit, the biggest cost reduction. Again, Elastic Cloud lets you do that out of the box quite easily. It's a little bit harder when you maintain Elasticsearch on your own, but it's something that's definitely worth it. That's on data tiering. And then I would want to first to also briefly touch on the metrics to monitor. So I mentioned them briefly when discussing right sizing, but I want to briefly show how it looks like and what to actually look for. I think the most important metrics is the load average. Load average, just to make sure we are all aligned, load average is the metric on Linux that would look at the how hard your computer, your server is working, and it is a factor of CPU and I/O, which is mostly disk. And out of that, it will give you a number. There's a number that's called load. Load is essentially the computation that tells you how hard your machine is working in terms of CPU and I/O. Now, load average is the average across several minutes usually. And we usually get 1 minute, 5 minutes, 15 minutes in pretty much every monitoring tool. And also Elasticsearch reports that. So if you look at load average 1 minute, it's an average across 1 minute. But when you look, and then you'll see spikes. But when you look in 5 minutes, it's more representative of what actually goes on. So it will actually show you some spikes, but not too sensitive. But the 15-minute will flatten those spikes, sometimes too much. So we recommend looking at the load average 5-minute metric, and then based on that, perform some intelligent sizing, and I'll show that in a second. Then we want to look at the heap memory usage. We want to make sure that the heap is cleaned up nicely. It's not spiking. With all their GC mechanisms, you'll see the jigsaw, the famous jigsaw, G1 GC. It will just look, more usually like a straight line, but you want to make sure that it's not spiking. Based on that, you want to make sure that there's no circuit breakers being tripped. And that's the main metrics for any machine. But again, the first metric we're going to look at is the load average always. Then we want to see how Elasticsearch is doing. So we are going to look at the thread pools. Thread pools is essentially the metric that will tell you out of all the important operations, and the most important ones are search and then write, we want to make sure that Elasticsearch is keeping up. And so Elasticsearch will allocate a certain number of cores or threads to execute tasks as they come in, as requests come in. And but it will be an allocated number. When you get too many requests there, more than the number of threads that Elasticsearch has assigned, those will get into a queue. And as the queue builds up, you may get rejections. So when you have requests in the queue, it means that you're serving slower than what you would probably could, because those requests are waiting in the queue. So you want to make sure that the queue is relatively empty, If it's empty all the time, then you over provision most likely. So you want to make sure that it's empty most of the time. It's not building up, and then that you don't have rejections. Sometimes we recommend to have some queue on the right side. So you have right queue, but we want to keep search as on 0 almost all the time. Again, to satisfy requests. If you want to optimize on cost, you can make sure that the search queue is building up sometimes, but not too much, so you don't get rejections. And then you know that you're not way too over provision. Obviously, if there's spikes, you're going to be pushing back a little bit, or maybe reject some queries. And then caches. Caches are very important to monitor. I'll talk briefly about them later today. And then shard balancing as well. So shard balancing is a little bit hard to track. We actually have a dedicated view for that on Pulse. But the idea is that you want to make absolutely sure there's no hotspots on the cluster. So let's quickly look at how Pulse does that. And so Pulse looks, one second.
I do have a couple questions around metrics. The one is talking about what's the maximum heap size currently allocated, and how does it compare to like the total memory? So I don't know if you want to. I think you had that in like initial slides, but I figure that'd be kind of good for this slide that we're talking to right now. So the maximum is you ever want to do is 30 gig, right?
Yep. And never above.
Yeah, and then typically it's half of what your overall memory is.
It needs to be no more than 30 gig, 30, 32, but we go with 30. So it doesn't, you need to have it maximum of 30 gig, but no more than 50% of the available memory. So sometimes it makes sense to have a machine with 128, 256 gigabytes of memory. You're still going to assign up to 30 gig for the JVM process because of JVM stuff. We're not going to that. But that other memory is still going to be very useful, because you're still going to make use of it because of some data structures that are off heap, and also because of the file system cache. So depending on what you're doing, especially aggregation queries, for example, make a lot of use of the file system, the files on the file system, and you want them to be memory mapped to the memory essentially. So you make as many scans as possible on memory. And again, depending on many factors, that could be useful. We would usually start with on large clusters with 30 gigs, 64 gigabyte of total memory, and take it from there.
And do you have do you set the for the heap? Do you set it to the max, and do you set it to the max on even small, like the XS? I've done that before. I've set it just allocated immediately to like 30 gig. I think I was running like i3 EC2 instances. Is that how you typically will do it, or do you do two different numbers on the heap?
No, it has to be the same number. It's actually written in the documentation, and there is a variable that controls that. Yes, heap size, and if you install yourself, you need to do it through that. It's in the JVM options file.
And then we had another question on how to efficiently manage bulk indexing.
So our recommendations, hopefully I understand the question right, but our recommendation is to optimize on network traffic and essentially what goes into disk. So the translog, and then the actual flashes that need to happen to disk. And then our recommendation is to use 10 to 15 megabytes per bulk, right? So, and that's also what, for example, Logstash will try doing. So you don't want to optimize for number of documents or something like that. You want to optimize for the amount of network or amount of data that you're pushing to Elasticsearch. Hopefully that answers the question.
Okay. And then the second part of the question was without impact in query performance.
Yeah, so that's a tricky one. Um, it might impact query performance, but depending why, that would the question is why. It could be just the machine being working harder, so more CPU and disk is being used, and that will essentially tell you that you probably need to scale out. So you'll probably need to have more cores, more memory to support that, or more disk. But the other reason for that could be because of writing to an index that you're currently reading from, and that's going to invalidate some caches. So depending again on what you're doing, if that's some sort of an append only index, that what I just said, that caches are being
Right.
validated, will be less frequent, or it will happen, but it will happen on a smaller scale. But if it's an index that you keep writing into and it's never being rolled over, for example, then you'll suffer more from that. And there could be different recommendations on how to fix that. But you need to try and understand whether it's a machine issue that, again, under provision you need to scale out, or it's one of those items. Also, and we'll talk about that in a minute, but also make sure that you don't do a lot of deletes and updates as much as possible.
Okay. All right.
All right, so I want to briefly show how we look at that in pools. So this is pools. It shows this is one Elastic cluster. As an example, a SIM cluster. We show various metrics here. We let you graph them over time, so you can track, how many nodes you've had, documents since the beginning of time, indexing and search rate, storage, all of that. And then we'll also eventually provide some sort of health assessment. Like I said, we wanted to do this basically to give you the bottom line as much as possible. If a check is going to fail, we're going to give you, for example, periodic backups. We're going to give you the recommendation on how to resolve that. And then if you click on that, you're going to get the actual description and the even command to run when we can do that. So we briefly discussed the dashboards. And those are the dashboards that we provide. And as you can see, this is a cluster with hot, warm, and frozen tiers. It can clearly be seen and indicated. We have a metric that we call search pressure and write pressure. That's a computed metric that we do. It's not something that's provided by Elasticsearch. It's something that we calculate. But in the end of the day, what you want to look at is the machine stats. So you can see the CPU percent. That basically tells me that you are very much high over provisioned here. You can see which tiers we're showing. So as you would imagine, mostly the hot tier, and then the heap used. The load average metrics looks like this. It's basically a number between 0 to some whatever. There's no max over there. What you want to make sure is that the number of cores that you have on the nodes is the load average that you have is not over that number. So if you go here, we can see that the hot tier nodes have 8 cores. So we want to make sure that the load average is not going above 8. And that doesn't happen. So this is the 5 minute. You can see that 1 minute shows a little bit more spikes, but it's never even getting close to 4. That tells me that this cluster is over provisioned, and I can do one of two things. I can either slice the machines down to from 8 cores to 4 cores, but that would bring me to a cluster with 4 cores, and a lot of relatively many nodes, but a small number of cores. And what I think is better in this case is to actually have less nodes. So that tells me I'm probably over provisioned on the hot tier. I need to have bigger nodes, but less of them. And I can also clearly see that the frozen and warm tiers are not doing anything, are literally a waste. And that's why we will probably recommend to also remove those from the cluster. So essentially moving the data that they have to the hot tier. There's no real reason to be on the hot tier. Those are the queues that we discussed. So Search queue size, as you can see, sometimes there is some queue. Write queue size, also sometimes some queue. If the queue is building up, there is some limits, there's some thresholds, and then you would see search rejections, write rejection coming in, and you definitely want to avoid them. Another way to get rejections, you're not going to see that now because that cluster again is too relaxed, is the circuit breakers. So the circuit breakers will essentially trip whenever there is a very high usage, or memory usage is too high. So Elasticsearch will try to protect itself. It will trigger a circuit breaker. The user will get a rejection, so like a thread pool rejection, but you will actually get rejection based on the circuit breaker, HTTP 429, and that will protect the cluster from, or the node from short circuiting and collapsing. So that's basically how we do sizing. We look at nodes, we look at all the metrics that are in the nodes themselves, and we try to understand what's going on and optimize from there. We can also look at disk usage and see, for example, here 17 terabyte is assigned, 9 megabyte is used. Obviously this is unusable or not being used and just a waste. So this is an example of how to measure performance, and in this case, how to size. Our recommendation about sizing down could be provided. So again, Pulse provides a lot of those dashboards. For example, on indices, we try to be smart about that. So the SIEM cluster will have a lot of indexes that go around events that are coming in from endpoints, from security endpoints, PowerShell, all of those. But those essentially are indexes, in this case data streams, that share the same name, have some data ingested into them, but then we can just tell that it's the same index pattern. So on Kibana, you'll define that index pattern, or SIEM will do that for you, and that will basically allow you to query all of those indices that share the same data over time, right? It's time-based indices. What we do here is we automatically collapse. We don't care how you define things in Kibana. We'll automatically understand what indexes you have, collapse them into those indices patterns, and then we can easily see which index patterns are being used the most for searches, for indexing, what are the biggest ones, which ones have the most documents or events in this case, and so on. Will allow you to do some interesting stuff like, because you may have many indices, same thing for nodes, you can drill down and graph them accordingly, and then those graphs here will be filtered by that. I mentioned shards, so we'll have this shard heat map that will show you whenever there's a hot node in this case, and from there you can drill down and understand which nodes are busier, why they're busier, and try to figure that out. It's probably some concentrations of shards and so on. That's Pulse. I want to switch back to the content unless there's any questions here.
And then what's the typical ratio from primary to secondary, like shards?
You mean primary and replicas?
Yeah, replicas.
That would highly depend on usage, and it's one of the. It's I think it's the next slide. Okay. You'd usually want to have more replicas when you experience some performance issues on reads. So once you have more replicas, essentially you're giving more CPU to that same amount of data, so the same data. So if you'll have, let's say, 1 gigabyte index served from one node of 8 cores and another replica from another node with 8 cores, and you're sustaining high search pressure on that index, adding a replica, assuming you have more available nodes, will basically give you 8 additional cores. And in that sense, the thread pools, the available threads for search, you'll have more of those. If I remember correctly, 8 cores means 13 available concurrent threads for search. There is this formula. I think 8 will give you 13 threads. So this goes directly to your question. Indexes and sharding strategy. That has a lot to do with performance and obviously cost. And we mentioned use cases. The use case will be will very much dictate how our recommendations or how our strategy is going to look like here. On the logs analytics use case, we'll see data coming in, being ingested, and basically like we saw now, so what's called now data streams. Previously, it was time-based indices, rollovers, all of those. So basically, one index is active, data is being written to the active index. Once it's being rolled over, you will still have that index for querying, but now indexing is going to the new writes are going to the other indices, and that provides a lot of room for optimizations. So data tiering that we mentioned, hot, warm, cold, is perfect for this. Is a great way to save money. Again, if you have enough data and you didn't scale out too soon. And make sure you're using data streams, make sure you're using rollovers. It's 2024 coming to 2025. There's no need to use time-based indices. Use data streams or rollovers. That will allow you to control the shard size per index. So you want to basically make sure that you have, let's say, again, depending on use case and everything, but let's say between 30 to 50 gigabytes per shard. And the only way that you can control that over time is if you use data streams and rollovers, because otherwise, if using daily indices, for example, weekdays could be 100 gigabytes per day, and weekends could be 10 gigabytes per weekend day, right? So that's really the way to do that. There are some interesting features like index sorting that are highly useful and provide a lot of performance improvements over there. And there's new Elasticsearch LogsDB. It's a new engine, essentially a new index engine that will highly optimize both performance and storage, specifically aimed for the logs analytics use case. Otherwise, if it's not the logs and analytics use case, there's plenty of optimizations that can be done. Basically, it all usually goes around the way to do partitioning. So questions that we get a lot of times is multi-tenancy, and should I split data between different indexes, or should I keep it all on one index, even though we don't have types anymore, and so on. The idea is to try and optimize for the same shard size, pretty much the same throughput per index, and then try to see how you can partition the data based on that. Again, it will highly depend on the use case, but that's something I would try. And then updates and deletes, Elasticsearch doesn't really like them. We all know that. It's always been like that. There are solutions around that. But if you have to do that, try to batch them together as much as possible. So we sometimes use, for example, Flink to consolidate some updates and deletes into fewer commands and things like that. There's tons of stuff that can be done. If you're doing a lot of updates and deletes, try to see how you can maybe do that less frequently. Another thing that we see a lot of times, it's been in slides that it's been in sessions that I've been giving for many, many years, and it's still the case. The relational mindset, meaning you used Postgres, you used MySQL, and you want to use Elasticsearch, but then you're basically enforcing what you know from there on Elasticsearch, is not going to work for you. You need to really do document-oriented design, and it will save you a lot of troubles. For example, updates, deletes, and many other things like that. I'm just putting it out there. It's a huge discussion, but it's something to really be aware of. Almost one of the last topics for today is queries. When we get questions or complaints about clusters being slow, it will usually revolve around slow queries, because that's when you really meet Elasticsearch. Your users are using Elasticsearch and queries are returning very slow. There's a lot of things that could go wrong, but usually it revolves around just a very, very few items. One is queries that are expensive. So some queries are known to be expensive. You shouldn't be using them, or you should be using them with caution. But people just don't notice. So instead of going through full explanations and going through each one of them, I put some links here to our blog where we basically go through them in detail. Obviously, it's all in the Elastic documentation as well. So queries like regex queries, script queries, so queries that don't go through the index, or queries that are being rewritten to be huge queries, so leading wildcards and short prefixes and some others, are queries that you should be basically avoid. There's usually solutions or alternatives to them. As an example, leading wildcard, usually you want to search for something that ends with. Then one of the solutions is to just use reverse token filter in your analyzer and then search in reverse instead of using the leading wildcards in your searches. Another prime example that we see for queries that are performing very slow is n-gram queries. If you know what that is and you're using it, stop doing that and go look at our blog. We have a couple of alternatives, built-in features in Elasticsearch. 95% is that you don't need that. Another thing that an optimization that I think is there for a couple of years now is tracking total hits. Elasticsearch will avoid giving you exact counts. You usually don't need that. If you disable that, know that you're getting some performance hits. And again, those are the prime items that we see. Another big thing that we see a lot is that queries are not cacheable. And by cacheable, I mean that the cache could actually be used to optimize your queries or to reuse queries or query parts. Again, we listed some examples on our blog. Go and read that. Review your queries. Make sure that you use cacheable queries. That's true for queries, but that's also true for aggregations. And both caches are query cache and request cache. Both are two important queries caches that you need to monitor, and make sure that you don't have a lot of evictions. Make sure that it's actually being used. Those are the things to note on the monitors. Once you do get to the point where you have slow queries, you review your queries, and your queries are still slow, or you have a lot of complaints about slow queries, then you might want to try and debug them. One thing that we usually see is that customers go to us and ask us to help them debug slow queries, and then we look at their cluster, and it's actually their cluster being malfunctioning or not performing at its peak, and that's what you would want to look at. So I'm just highlighting that. Before looking at your queries, actually go and look at your infra and all the advice that we've given so far. You review the monitoring to make sure that there's no bottlenecks, and if there are, try to fix them. Do node right sizing, indexing and sharding strategy, and reach that goes to your question. Add more replicas to your indexes if it's not fully replicated and they're suffering a lot of throughput. Once you've done all that, then we can start discussing how to debug slow queries if they still persist. And then the advice you'd usually find is to go and use the slow logs. Slow logs is a feature in Elasticsearch that will log queries that are slow. And the problem with that is that when you do that, when you enable that, you're basically asking Elasticsearch to log all queries that are slower than 1 second. And then you'll be looking at all the queries that are slow and have 1 second latency. But again, maybe the problem is with the infra. Maybe the problem is with noisy neighbors, so other queries that are slow. And that's something that you should be aware of. You could start with that, but again, just be aware that you're not necessarily be looking at the real problem here. So you can go and debug that specific query that you got with the profile API. With Pulse, we took a little bit of a different approach. We've created a feature that's called Query Analytics. Query Analytics will essentially ask you to deliver all queries to the system. So we want to see all queries. We don't have to see the results. We just want to see the query source, maybe anonymized if you have PII, and then some metrics. So the number of hits, the request size, the response size in terms of bytes, and so on. And then based on that, we'll try to categorize those queries to what we call families of queries. So we'll do pattern matching, we'll do a lot of smart things, and we'll basically be able to tell you, this is a query that repeats itself. The structure repeats itself, or we kind of see that it's the same query, even if the values are different. You want to go and chase the guy that wrote it, or the part of the application that runs it, and optimize that. And it's slow because it uses cardinality aggregation. It's slow because it's tracking total hits. It's using queries that are not cacheable, and so on. So basically all the things we saw and little more. And because we see all queries, we can basically single out the patterns that actually create the slowness. So that's on the query side. Last but not least is vector search. I do want to touch on that. I know we are maybe a few minutes of the time, but I'll still do that. Vector search is a huge topic, and there's tons to say about that, but just a few important bullets. So on small data sets, you should probably use KNN, and that means exact. On the documentation, it's called exact ANN or exact KNN, I think, but it's exact lookup for vectors. On small scale, I would say up to hundreds of thousands, or maybe up to 1 million of vectors. If you use KNN, the only thing you're going to pay is with CPU, and it's still going to be fast. Once you go beyond those few millions, then it's basically O of n, and then that would mean the query is going to be slower and slower, and that's when you probably need to start using ANN. So the most used algorithm is HNSW. Elastic does it very well, and essentially it's approximate nearest neighbor. Then you go into some points of how is my precision and so on, but you cannot really rely on the CPU anymore, and you need to start using more sophisticated approaches to that will optimize it, and that will also use memory. So you need to start tracking that. There's some advice on how to optimize that further. So for example, more aggressive segment merging, so you can get to larger segments, and hopefully that speeds up things further. And then maybe quantitization methods. That's a little bit of a more advanced topic, but if you can get the same precision, the same results for a 1,000 dimensions vector by using only 100 dimensions because of some advanced data science techniques for quantitization, that's probably something you want to look at because it will optimize storage performance and so on. So those are the big bullets around performance and obviously cost for vector search. I'm pretty much done. If there's any questions, happy to answer them. We are at the QA session, the QA part, Q&A.
There's lots of questions.
So
I don't know if you want to look through the comments to kind of pick out the ones that you really haven't covered.
All right. Yeah, we have a lot of questions. I didn't look at that until now. So essentially, if you want to get on Pulse, you can scan this QR code or go to pulse.support. You have a get started over there, and we'll be happy to give you an extended trial of the platform. And let's quickly look at the questions. Okay, that's actually a lot of questions. I answered this, answered that. Okay, how to configure Elasticsearch storage size retention globally to avoid crashes in Kubernetes. I'm not sure I understand that. I think what you mean by that is that storage disconnects on Kubernetes for you, and Rich, you have to teach me how to do that. And then I think what if that's the question, then you just need to use PVC, which are persistent volumes and persistent volume claims in Kubernetes, and that will do that for you. If you're going to use the official Elastic provided way to deploy in Kubernetes, I think nowadays it's either ECK or Helm charts. I don't remember what's the official advice nowadays. It should do this for you. What are the metrics that you can observe in the monitoring indices? Do you use to determine that you have the right sizing of number of data nodes, master nodes, ingest nodes? So I would not necessarily look at indices, actually. I would look at nodes. So the top metrics that we look at is the number, again, the load average. We want to make sure the load average 5 minute is not above the number of cores that we have available. And then the heap size, circuit breakers, thread pools, cache usage, all of those. And we need to weight that with the performance that we get from searches. So maybe everything is quiet, but you don't get the performance that you want because caches are being evicted a lot. So you want to spread out the data even further. So there's a lot of parameters over there. I would not look at the actual indices. I would look at the number of the data of the nodes, the node stats. Maximum heap size we covered. Thresholds are in place for alerts on high memory usage. I don't know if you talk about in general or on polls. We actually don't do that with polls on lower thresholds. What worries me about memory monitoring is the circuit breakers. So how fast the circuit breaker memory, the thresholds that it looks at, how fast it's filling up, and also GC metrics. So I could monitor the heap size and tell you if it goes above 85% or 75%. But I think the more useful is to tell you that GC is not keeping up, or that you're close to hit a circuit breaker. And that's what we usually do. Like I said, I'm not a big believer of threshold alerts. I want to try and find the root cause or the more interesting parts of the metrics and alert before something happens. Do we have more time for more questions? You let me know when to stop.
You can keep on going. A couple more if you want. I mean, I think some you have really covered. I don't know if you just take a look to see what wasn't.
Bulk indexes we covered. Recommended shard size for optimal performance. This is a good question. So the right answer is there is not one number for all. It really depends on what you're doing. Like I mentioned, on vector search, you would want to have less segments and bigger segments. And obviously, that could also influence the shard sizes. On text search, we saw that on many performance testing that we've done, we saw that the number of documents is actually the interesting number, not the actual size on disk on many cases. And then, optimal shard size could be 100 gigabytes if you are ingesting a lot of data and hardly search on that. So you have better density of data on storage. And other parts, you can optimize by parallelism of queries if you have a little bit smaller. So the official advice is to keep it to 30 up to 50 gigabyte per shard. It also helps with when shards are rebalancing on the cluster. But it's very much use case dependent. Let's pick two more.
Let's see.
What monitoring tools are in place to track cluster health and performance? Again, I'm not sure what this refers to, but obviously there's the built-in Kibana monitoring. On Elastic Cloud, you have the Elastic Cloud monitors. And obviously, we've built this tool because we also wanted to cover the applicative usages So Pulse is a monitoring tool that we love and cherish. Okay, how do we balance shard allocation across nodes to prevent hotspots? This is interesting. So it's hard, but what we did is we track shard stats events. So there's no shard stats, but there's the shard in the cluster stats. You have shards information and shard mappings and metrics around that. So we basically look at all the shards on the cluster. We measure indexing and search performance and their size. And then we have developed an algorithm that does some dynamic programming and some algorithms to basically get you to the best point possible, best balance possible based on those metrics, with the minimum number of rebalances or movements of shards. It works nicely. It's a little bit dangerous, so sometimes we need to be cautious and actually monitor when we do that. But that's part of what we do, and that's our approach. Unfortunately, Elasticsearch out of the box will not really do that. So we have to revert to external tooling to do that. Cool, Rich. If you see any other interesting question or you have any.
I think you really have covered them all. Definitely throughout the presentation. I think as if they look back, they'll see that you have provided an answer. So why don't we reveal the winners?
Yeah, but first of all, thank you for having me. And hopefully this was helpful for everyone. And feel free to reach out.